Okay, I just wanted to do a quick video to just summarize the different formulas that appear in the sequence and series chapter. So starting with arithmetic, the nth term of an arithmetic sequence, which we could say was an, is equal to, well, we have got the first term plus n minus 1 times d. So you're starting with the first term and you're adding on n minus 1 lots of the difference. And I'm going to say you need to remember that. You need to remember that. Okay, the sum of the first n terms, which we write Sn, well, one way to write this is it is n over 2, the number of terms, divided by 2, in brackets 2a plus n minus 1 times d. And in my previous video I proved that, and you do need to remember how to prove it, but this is in the formula book, but need to be able to prove. So you need to remember the proof, but you don't need to remember the formula. Now there is an extra thing that I didn't mention, one of the reasons I wanted to do this video. If you define L to be the last term in the sequence, then it will just be, if you have n terms in the sequence, it will just be this. It will just be a plus n minus 1d. Well, you can actually change this formula, and you can actually see that Sn will become, it's still n over 2, but since a plus n minus 1d appears in this brackets with one extra a, it will just be a plus L. And that is also in the formula book. And finally, for the arithmetic sequence, we have the sum to infinity. Well, with an arithmetic sequence, the sum to infinity is just going to diverge, so there isn't a sum to infinity of an arithmetic sequence. Okay. For a geometric sequence or series, well, the nth term is going to be equal to the first term multiplied by n minus 1 lots of the common ratio. So the first term is a, the second term is going to be ar, the third term ar squared. And you need to remember that. You need to remember it. It is not in the formula book. The nth term of the sum of the first n terms is going to be equal to a, open brackets, r to the n minus 1 divided by r minus 1, or a, open brackets, 1 minus r to the n over 1 minus r. So these are exactly the same, and you can use either whenever you like. But it's more easy to use this when r is greater than 1 and when r is less than 1 for this one. This is in the formula book. But just like for the arithmetic, you need to prove. You need to prove that. Okay, and finally, with a geometric sequence, and this is really crucial, if r is between minus 1 and 1, not equal to minus 1, not equal to 1, the series converges, and we have that Sn is equal to just a over 1 minus r. And for that, that's for the reason that r to the n, in this formula here, r to the n will go to 0. If r is not in that thing, so if r is less than or equal to minus 1, or r is greater than or equal to 1, then it diverges. It diverges, and it doesn't converge to an a mistake there. I'm going to change that. It's sum to infinity. Sum to infinity, we use that symbol there. And this is in the formula book. This is in the formula book. Okay, that is a summary of all the formulas. Remember, you've got to remember the nth term, but the other ones are in the formula book, and those are the formulas for arithmetic and geometric series.